All right, it's recording now, so. This will be on my webpage. You can get the first 6. I worked through those first 6 problems on the front of that page. I worked those through last period. So tonight, a way that you could review for our test tomorrow is to go to my webpage and watch the videos. Okay? There'll be problems that are like this. It picks up at number 7 for y'all. So y'all have seen this part, so there's not really reason to watch this. Also, some good problems that you can do that are very similar to the ones that are on our test, because a lot of the test is multiple choice. That's what we're trying to get you ready for, is page 54, 1 through 24. Tomorrow morning, I'll get to class I'll get up there about 6:45, 6:50, somewhere right in there. You're welcome to come up here, and if you have a question on some of them, I'll be glad to work through it. Along those lines, page 54, guys, page 54 starts out with this problem here. It says a clock loses 5 minutes every day. How much time will it lose in 2 hours? That's those conversions that we've been talking about. So if I had 5 minutes in one day, and it said I wanted to convert that to a certain number of seconds per hour. So remember how we set these conversions up. The first thing I need to do is change my days to hours. So because it's on bottom, I need to put 1 day on top so that can cancel out. And 1 day is 24 hours. So I got a 24 hours on top. And then I notice I need to change the minutes to seconds. So 1 minute is 60 seconds. So now, what I have, I can cancel some stuff out here. I can cancel out days out. I can cancel out minutes. And then what I end up with is 300 seconds over 24 hours. And so I now have converted 300 over 24. Is that a good answer? 12.5 seconds per hour. So I converted that from minutes a day to 12.5 seconds per hour. But notice what the question says. A clock loses 5 minutes every day. How much time will it lose in 2 hours? Well, we figured out that it loses 12.5 seconds per hour times 2 would make that 25. Page 54, problem 1 through 24, the answer to the first one, so you can start on it, you can get an idea. Don't feel bad about it. The answer to the first one is A. The review I gave you yesterday, a lot of what was going on was there was some review stuff on there and some preview stuff on there, just for me to kind of get an idea. One of them is I won't ask you to solve literal equations or factor tomorrow, but I kind of wanted to see where we were at in being able to do that, so I can know what's going on with our next chapter and stuff. If you were asked to solve an equation for m, and we started out with y equals mx plus b, there would be several things that needed to be moved. One of the things that needed to be moved would be the plus b. How do you move a plus b? What do you do? Now, y minus b, guys, y minus b, you can't solve anything for. You can't solve anything for y minus b because they're not like terms. So you just write it out. Okay? Let's look now at the next thing we have. We have m times x. What's the inverse of multiplying by m? So I'd put divided by m. Oh, I'm sorry. This says solve for m, so I wouldn't divide by m. I would actually divide by x. I'd have y minus b over x equals m. What is this formula? Area equals 2W plus 2L. That's the formula for what? That's the area, or excuse me, that's the perimeter. That's really the perimeter of a rectangle. But using something here, it says A equals 2W plus 2L. So for whatever reason, the problem was changed to an A. If I were going to solve that problem for W, I would need to move a plus 2W. Or excuse me, a plus 2L. If I move a plus 2L, the way I do that is by subtracting 2L. And then divide by 2. Now, the thing that's interesting about dividing by 2 is you can kind of write that a little bit different way, and I could end up with 1/2 A minus L equals W. Certainly wouldn't be odd that the problem would be like that. I'm doing the distributive property here. I just want to make sure you can't tell what that number is, but it's supposed to be an x squared. So what I'm trying to get you to see is what property? 5x times x is 5x squared. 5x times 3 is 50. I'm just trying to talk about the distributive property. Let's say I ask you to distribute a 7, it's 16, so it wouldn't be a 7xy. It would have to be a 2, so a 2xy. So if I wanted you to multiply 2xy by some number that would give me 16, that would be 2 times 8. What would I multiply xy by to end up with x squared y? 8x. What would I multiply 2 by to end up with a 24? So minus 12y plus 7. So the point I'm trying to get you to see is now let's take this problem and distribute. When I take this problem and distribute, that means I have to multiply it by each individual term in that problem. So I do 2x times 8x, 2x times 12y, and 2x times 7. More than factoring, I want to show you the distributive property. The distributive property shows up all over the place in our problem. Just so we're here, because I want to make sure I talk about these first 3 problems, because this is very similar to the first 3 problems on our test tomorrow. Because here's why I'm going over distributive property. Look, the product of 6. I know product of 6 is 6 times something. But the only way I can multiply 6 times something, if that something is 2 plus n, then 2 plus n I have to put in parentheses so that I distribute. The same question shows up like this in the second half of the test. I give you a problem and ask you to distribute it. Remember, if I give you a number and ask you to distribute 5x times x, you'll end up with 5x squared. Then you take 5x times 3, and that gives me 15x. So this is more realistic about what will be on the test than asking you to factor something. Questions? You don't have to really graph on it, but you do have some substitution stuff. If you had a graph here and you were going to graph this stuff, this is more, again, one of those review kind of things, or kind of see where we're at. When I think, how do I graph the point 0, 3? Do I go up, down, right, left, and then up 3? That's right. 1, 2, 3. How do I graph 1, 5? I go right 1, up 5. Right 1 and up 4, 5. Right 2 and up 7. Right 3 and up 9. Right 4 and up 11. And so those things end up in a little straight line right there. If the trend continues, will 5 be 20? No. How much are these going up by? 2. The y's are going up by 2, while the x's are going up by 1. So I'm not all of a sudden going to go from x equals 5 to y equals 20. I'm more likely going to go from x equals 5 to y equals 13. How do I substitute into this equation? I just put -4 right there. I just put -3 right there. I just put a 0 right there. 2 goes there, 5, 2 goes there, 9. When I graph these things, I end up right there. And these points right here, these points correspond to, there's 0, 3. There's -3, 0. -4, -1. Because that's that point right there. 0, +3 is right there. 2, 5, over 2 and up 5. That's the point 2, 5. As these points correspond to places on the graph, they aren't just arbitrary bits of information. Find the unit rate. How do we find the unit rate? We say you drive 355 miles on 15 gallons. So is that a good final answer? No. How do I find that answer? I take my calculator, do 355 divided by 15, and like you said, I get 23.6 repeating. Now, guys, this question is going to show up a bunch of different ways. Yesterday I tried to show you this question, and when I tried to show you this question yesterday, it was in this form right here. This table, almost exactly like this, is on the test. It's on the test, and it says compare the rates between a squirrel and I don't know, I'm picking something, a rabbit. So if I had a squirrel and a rabbit, I would have 12 over 35. 12 over 35 won't reduce, so I can't reduce it. Maybe I had, I don't know, I'm trying to find something that will reduce it. A mouse and a reindeer. If I asked you to compare the speed of a mouse to that of a reindeer, you would get 8 over 32. Will that be a good final answer? No, 16. 2 over 8. 1 over 4. But your calculator is not going to say 1 over 4 when you reduce it. Your calculator is going to say, with them. So just realize that's what it's trying to figure out. It's the same question, it's the same question that we're asking here. It's the same unit rate. You find it the same way. You spend $90 on 4 shirts. So if I spend $90 on 4 shirts, then 90 divided by 4, 22.5. So it's 22.5 is your price per shirt. 5 minutes later, 355 miles on 15 gallons, 355 miles on 15 gallons. I ask you to convert that to ounces and yards or something. Remember, all you do is if you're trying to convert to yards, and if I did that, I would have to give you some conversions. I would have to tell you how many yards there were in a mile. But if I wanted to make this, I put my mile on bottom and 1,760 on top. And now you just converted that to yards per gallon. Instead of gallons, if I wanted you to have ounces, to convert that, again, because gallons is on bottom, I would times that by 1 gallon, which is 128. This is why I would have to give you the information. Ounces per gallon. 128. And so I'd have 128 ounces here. Do you see anything that would reduce? Miles, gallons. And now I still use the number, so I would have 355 times 1760, and that ends up with the number of yards per ounce. 15 times 128. And that's how, guys, that's how you convert. We did the football player that was running a 40-yard dash. We did the baseball pitcher who was throwing the base. And those conversions, as that's all we're doing right there when you do those conversions. Again, page 124, page 54, 1 through 24. If you have some questions on it or something like that, it's real good questions that are like on the test, because a lot of the test is multiple choice. The reason I'm giving you a multiple choice test is because, remember, at the end, we've got to be able to do good on our EOCT, which will be in a multiple choice test. All right? The first 6 problems are on my website. I'm going to stop this now, and then this part will be on the website.